Hello, this is Mrs. Thompson, and at this time we will visit right triangle trig. We will begin with reviewing the parts of a right triangle. The side opposite the right angle is always called the hypotenuse. Right angle, hypotenuse, the side opposite it in location. The hypotenuse is always the longest side of the triangle. Of course, there's also the opposite side and the adjacent side. The opposite side is always opposite the angle you're working with. So here, opposite theta, and then there's always a side that is adjacent to the angle you're working with. We have very important information here that you should learn if you do not already know it, and that is the definition of all 6 trigonometric functions using the parts of a right triangle. To help you remember these definitions, some people use the sentence, "Some old horse caught another horse taking oats away." Of course, the first letter of each word in this sentence reminds us of our trigonometric functions and their definitions. Precisely, the sine of an angle is equal to the length of the opposite side over the hypotenuse. The cosine of an angle is equal to the length of its adjacent side over the hypotenuse. And lastly, the tangent of an angle is equal to the length of its opposite side over its adjacent side. Of course, the cosecant definition is just the reciprocal of the sine. Secant is the reciprocal of the cosine definition, and cotangent is the reciprocal of the tangent definition. Another popular way of using this is to take each letter in bold. So the first letter of each word in the sentence and pronouncing it as a word. That word would be pronounced Sakato. So if you have used that in the past, it still works. Strategies for solving right triangle problems. First, strategy. Use the Pythagorean theorem to find the length of a third side when the length of 2 sides are known. Second, use the trigonometric ratios, also referred to as the trigonometric definitions from the previous slide, to find missing sides or angle. So to find the length, unknown length of sides or unknown angle measurements. And lastly, use the fact that the sum of the measures of the angles of a triangle is 180 degrees to determine a third angle when 2 are known. An example, evaluate the trigonometric function of a right triangle. Given the right triangle, evaluate the 6 trigonometric functions of the acute angle theta. So in this triangle, we are given the length of 2 sides. Those lengths are given in black. So we have a length of 4, a length of 9, and of course we see angle theta that we are asked to work with. Where the Pythagorean theorem tells us that the adjacent side squared plus the length of the opposite side squared will equal the length of the hypotenuse squared. So we can plug in 4 for the adjacent. We do not know the length of the side opposite angle theta. We're solving for that. And then, of course, the length of the hypotenuse is 9. or operation, we have to square first, so we end up with 16 plus the length of the opposite side squared equals 81. Solving for the unknown by subtracting 16 from both sides of the equation gives the opposite side squared equals 65. And therefore, the length of the opposite side is the square root of 65. Length is always positive. And as you can see, after solving, that length has been placed on the triangle in blue. Now that we know the lengths of all three sides of the triangle, all we have to do is plug them in the formula and in the various formulas, and we will have the values for this particular triangle for all 6 trig functions. There are 2 special right triangles that are very useful when studying trig. The first one is the 45-degree, 45-degree, 90-degree triangle. We see that here. At the bottom, the angles are in radian. In the sentence, we have the same angles in degrees, same angle measurements in degrees. The other special right triangle is the 30, 60, 90-degree triangle. And of course, you see both at the bottom, along with the length of the hypotenuse, adjacent side, and opposite side for both. Here, you are given the sine, cosine, and tangent for both special right triangles. It's wise to learn this information. Now, with our trig functions, we can perform all 4 operations: addition, subtraction, multiplication, and division. So just looking at an example. This time we're asked to find the cosecant of pi by 6 and add to that the cotangent of pi by 4. So in short, you always evaluate the trig function or the trig portion and then perform the arithmetic operation with those answers. So, evaluating the trig portion, cosecant pi by 6. Well, that's an angle on one of our special triangles, special right triangles. The cosecant of pi by 6, cosecant hypotenuse, which is 2, over the opposite side for that angle, which has a measure 1, letting us know that the cosecant of pi by 6 is 2. We can replace the cosecant of pi by 6 in the original problem with its answer, which we have now found to be 2. Moving on and evaluating the cotangent of pi by 4. Definition of cotangent, adjacent over opposite. As we can see for pi by 4, the adjacent side and the opposite side both have a length of 1, and 1 divided by 1 is 1. So the cotangent of pi by 4 is 1. We can always replace something with what is equal to. So replacing the cotangent of pi by 4 with 1. Final step is addition. Of course, 2 plus 1 is 3. This last slide just shows another way of thinking about the definitions of our trig functions. You should be able to think about and recall the definitions of our trig functions using the method here on this slide, as well as the method involving the 3 sides of a right triangle. This method reminds us that our trig functions result from a point. And that is the point, as we learn much earlier in this course, they could be viewed as the point where the angle intersects a circle. Up until now, we've always dealt with a unit circle, unit meaning a radius of 1. But if the radius is not 1, it can be found by taking the square root of x squared plus y squared, by taking the square root of that sum. And therefore, the definition of the sixth trig function is as follows. This is the general definition, regardless of whether the radius is 1 or the radius of the circle is more than 1. Of course, the nice thing about these definitions is we can use them whether the circle is drawn or not. So, of course, you should also learn these. Here, x and y, again, referring to the x and y value of a point. On the terminal side of the ray, r standing for the radius. And we have a formula for finding the radius given the point.